Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azmi bin Umar Hatta from BMMD 102. Currently, I'm doing my internship program with Petrofec RNZ, and my supervisor name is Ayar Hisham bin Ismail as a manager of mechanical department and assisted by Mr. Hamzaini Hamzah as a senior piping engineer. I have been placed at the piping and mechanical department, and my job scope is to assist engineer related to any engineering scope. Alright. So as a background of my company, Petrofec RNZ is established in 1993, leading provider of engineering and consulting service to the involving offshore oil and gas sector. Alright, Petrofec RNZ have a strong domestic market in Asia Pacific region as well as growing international business. Complement the full capability of the Petrofec Group by adding significant value to its offshore engineering, procurement, installation, and commissioning offer. Alright, RNZ offer that multidiscipline and fully integrated engineering services in design, procurement, construction, and commissioning. So this is a bit view of Petrofec RNZ, which is they provide a field development, conceptual studies, feed detail design, brownfield engineering, pipeline design solution, post engineering support, and project management. So Petrofec RNZ is located along the Malaysia, which is the Great Eastern Tower as a head office HQ. It is my place during my internship, and they also have at the Kerteh, Terengganu, mostly for the designing, and Bintulu design office at the Sarawak. Alright. So this is my role and responsibility during my internship program. Alright, so the first one is update piping specification from Petronas Material Specification Code PMRC. I will tell you later the detail of the PMRC. I have transferred and compiled the data such as size, description, code, item particular into piping proposal management system. The second one is extract PMRC. Extracted all the datasheet for valve from the Petronas database by using PMRC code. The third one is material takeoff, such as valve. The function of material takeoff is to identify and list of the valve under piping demarcation based on piping and instrument diagram. Transfer and compile the valve details such as PID number, line number, valve number, class, rating, and other information. So the next one is preparing datasheet of SP item. SP item is stand for special item that we use in this project. Alright, so datasheet contains the detail of special items such as pressure, temperature, material, type, and location. For example of the special item is flame arrestor, sampling boom, sampling connection, and insulating gasket. Alright, the next is valve critical analysis. During my study, I have studied about the human factor, and I can practically use in this project. So VCA or valve critical analysis is to ensure the valve is follow the specification from PTS. So this is include the position, size, type, and location. And the last one, preparing an issue isometric list to extract based on WBS. WBS is stand for work breakdown structure, that every location in the plant have a specific WBS. Alright, so I have do incorporate comment before extracting isometric drawing and extract isometric drawing and PCF file by using SP3D. Alright, so during my undergrad, I've studied the software such as SolidWorks, CATIA, AutoCAD, but in this company, we use SP3D for the piping. Alright, so this is PMRC. What PMRC provide is the specification report for material, service, pressure rating, and wall thickness. This is a mandatory additional requirement for material testing and inspection. Alright, so after we have the code, we need to extract the datasheet via the database from clients such as Petronas or Shell So shall we use merge number, not the PMRC, but this is the exactly same type of the code. Alright, so PMRC datasheet is additional attribute can be populated from the datasheet creation, which is from the database. It's a function for EPCC reference for packaging actually. Alright, so the next one is PMRC 3D loadable file, which is EPCC reference database, catalog and specification to simplify 3D model development. Okay. So this is example of piping metrification that contain of the PMRC code. I will show you the PMRC code how they look like. Alright. So this is the mandatory report that we need before we can model the product or piping. Okay. So in this report we will have the item, size, the description, which is contain what the type of the item, materials, the connection and con, and some more. Alright. So we also have the piping rating class, which is at the above 1C145AE. So the means of the numbers is specific actually. So I will go through one by one actually. Okay. So commodity code is alphanumeric expression of max 30 digits that contain item description, rating, standard, and end preparation material. So this is PMRC code that contain a unique expression identifying an item with its dimensional data, size, and schedule. So what we can know that every items have a different PMRC code. Okay, so PMRC code contains size, schedule, alias, and preparation, rating, material, dimension, standard, and group part. So the below is piping datasheet that contain the details of the items such as valve. We have size, class, materials, uh, types, face pattern, closure member, and some more. So this is a very important during the process of in the project. All right. So this is a meter takeoff look like that I mentioned before. Okay. So actually meter takeoff will do in two times from PNID and isometric, which is this is isometric that I show you. Alright, so the first one we need to identify which is the material and specification is follow the standard that we have been clarified with the client. Bolting bolts, the length and the size of the bolts, tagging number, which is we have valve tagging, instrument tagging, and some more. And the last one is insulating gasket, which is when we have two material, we need have insulating gasket at between of the two material to reduce the corrosion during the process. Alright, and this is a valve critical analysis. Alright, so valve critical analysis is like the human factor, which is based on the PTS 16.74.02. We have a standard how the height of the valve need to be. It cannot be less than 230 mm and cannot exceed above 1830 mm. Alright. So this is other activities that I did during my internship. Attended PMRC training by Petrofac RNZ. Attended piping proposal management system by Sharjah. Actually, Sharjah is one of the branch for Petrofac outside of Malaysia. Being the focal person for meeting with vendors, so I will set up with the vendors, which is with other company, to discuss the technical and requirement and datasheet of equipment. Attending mechanical community of practice COP discussion with Sharjah also, and I involved in EPCC project Bintulu additional gas sale facility 2 Petronas Carigali Sdn Berhad, and FIT project FC Villat compression project Sarawak Shell Berhad. Okay. So that's all from me. Thank you very much to Petrofa Aranzak and Sir Dr. Ikhwan Ghazali from UTEM. Assalamualaikum.